Welcome to this video on the AutoSys Google Cloud Run solution. In this video, we'll provide a high-level introduction to how AutoSys integrates with Google Cloud Run to automate and monitor container-based workloads, and the value it brings to the AutoSys community. You'll learn about the core integration components, the deployment sequence, and how Google Cloud Run services and jobs are triggered, executed, and monitored from AutoSys. Finally, we'll walk through a high-level demo. The Google Cloud Run plugin extension connects AutoSys with Google Cloud Run, so you can deploy, invoke, and manage containerized workloads in a fully managed serverless environment directly from AutoSys. It supports both Service Account Key and Google VM Profile authentication, so you can securely run workloads across different Google Cloud environments. With this extension, you can deploy and invoke Cloud Run services, invoke existing Cloud Run services as part of larger automation workflows, deploy new services or update existing ones directly from AutoSys, orchestrate serverless workloads alongside batch, on-premises, and cloud-native jobs from a single automation framework. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizes these processes with other non-cloud operations. Integrating Google Cloud Run allows us to configure process automation centrally in AutoSys. Subsequently, we can execute and supervise all processes from a single interface. These Google Cloud Run processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to effortlessly execute and monitor Google Cloud Run through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Simply define your Google Cloud Run and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are clearly indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of Google Cloud Run. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premises workloads. The job submission sequence is relatively simple because all Cloud Run execution properties are stored in the AutoSys POJO job definition. We will use Service Account Token authentication for this demo. All target system properties, including the endpoint, token, and execution parameters, are specified using J2EE job parameters. These parameters may vary depending on the authentication method used. The integration involves three main components: the AutoSys scheduler, the system agent, and the Google Cloud Run. The AutoSys scheduler submits the POJO job to the system agent. The system agent receives the job and then initiates communication with Google Cloud Run. The system agent authenticates Google Cloud Run using the credentials defined in the J2EE authentication parameters. Once authenticated, the agent submits the execution request to Google Cloud Run using a REST API operation. Google Cloud Run identifies the specified service or job and starts the execution. Google Cloud Run returns a JSON response containing execution details, such as the service or job invocation identifier. Both the Google Cloud Run and system agent then monitor the execution status until the workload reaches its final state. Once the final state is obtained from Google Cloud Run, the job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer, path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses Google Cloud Run Public REST API. We will run a Google Cloud Run Pojo job from AutoSys. First, let's establish communication with the Google Cloud Run. After establishing communication, we can trigger and monitor the Cloud Run service execution from AutoSys. Let's explore the Cloud Run workload execution within the Google Cloud environment. Let's start the demo. Start by logging in to the Google Cloud Run console. From the navigation menu, select Cloud Run. This web-based console allows you to manage Google Cloud Run resources, including services and jobs. In the Cloud Run environment, you can access sections such as services, jobs, worker pools, domain mappings. From the left navigation pane, select Services. This view lists the Cloud Run services that represent your deployed applications or APIs. Each service runs a container image and automatically scales based on incoming traffic. Open one of the services. From here, you can review service details such as the deployment configuration, revisions, and runtime status. You can also access logs to troubleshooting issues and validate service execution. Next, select Jobs. Cloud Run jobs are used to run container-based workloads that do not serve live traffic. Jobs are typically used for background processing, scheduled tasks, or batch-style workloads. Open a completed job. Here, you can monitor the job status and view execution history, including when the job ran and how long it took to complete. Select an execution ID to review execution details and click View Logs to access the job logs. Next, let's proceed to log in to AutoSys. Click the Quick View tab to review the job definition. Select the Create and Run job to open its details. For this demo, the job uses Service Account Token with a proxy. With the job open, click Quick Edit to view the required parameters. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name Google Cloud Run, and the second is the method name Create and Run. Now let's look at the gateway parameters. Understanding these gateway parameters is a crucial step in the process. The endpoint parameter indicates where the Google Cloud Run service resides. The token parameter authenticates with Google Cloud Run services using either a file or a concise JSON of the file contents. The project ID parameter identifies your Google Cloud Run project by its name or number. The region parameter indicates the geographical region where Google Cloud Run jobs will be executed. The Create Payload parameter specifies the JSON payload required to create a Cloud Run job. The Run Payload parameter specifies the JSON payload required to run a Cloud Run job. The Job Name parameter specifies the name of the Cloud Run job to create or run. The Delete on Completion parameter specifies whether to delete the Cloud Run job resource after a successful execution. Then we have proxy parameters. The proxy hostname specifies the hostname or IP address of the proxy server to which the connection is established. The proxy port indicates the port number the proxy server uses for communication. The proxy username is required for authentication with the proxy server. The proxy password is the password associated with the username. The max retry parameter is crucial as it determines the maximum number of attempts the job status will be fetched from the Google Cloud Run server for monitoring purposes. The sleep interval parameter specifies the duration of time the system agent should wait before querying the Google Cloud Run API again to obtain the job status. In the event of a brief downtime experienced by the Google Cloud Run service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. Lastly, the log level parameter specifies the level of logging information that should be included in the log file. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. After verifying all parameters, select Start the job and click Go. When prompted, click Yes to confirm the execution. The current run number for this job is 9557. After the refresh, a new run is triggered, and the run number increases from 9557 to 9558. A success status confirms that the latest execution completed without issues. To view the spool files, scroll down to the spool files section. Select the required spool file, click Go, and specify the number of lines you want to display. Reports for all statutes are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. Make a note of the job name ending with 88DD. We will use this job name to verify execution in Google Cloud Run. Now, let's switch back to the Google Cloud Run console to confirm the execution status. As you can see, the job name generated by AutoSys matches the job name in Google Cloud Run, and the Cloud Run job execution has completed successfully. That wraps up the demo on how Google Cloud Run workflows are triggered, executed, and monitored from AutoSys. Thank you for watching this video.